Okay, today we're going to be talking about some special quadrilaterals. So first, what is a quadrilateral? Well, right up here we've got the definition, and that is a quadrilateral is a polygon that has 4 sides. So if you think about some shapes with 4 sides, you probably already know or have at least heard of a lot of these shapes. But we're going to actually learn about their definitions and properties today. So the first quadrilateral that we are going to talk about is a parallelogram. Think about the word parallelogram. It kind of sounds like parallel, right? So that's actually one of the properties. So right up here, the first part is the definition. So by definition, a parallelogram has 2 pair of parallel sides, right? And that kind of matches a parallelogram. So in order to be a parallelogram, all I need to know is that the opposite sides are parallel. And so remember, to show parallel sides, we show an equal number of arrows on the lines that are parallel. So like those 2 sides are parallel. And then these other 2, I'll do 2 arrows to show that they are parallel to each other. Now, once you know it's a parallelogram, there are properties that we know about parallelograms, and that's everything down here. So the first property is that opposite sides, not only are they parallel, but they are also congruent. So remember, to show congruence, we use the tick marks. So those 2 sides are congruent. And then these 2 sides are congruent. So there's a difference between just being parallel and being congruent. We also know that opposite angles are congruent as well. So what does opposite mean in terms of this quadrilateral here in the parallelogram? Opposite is across from each other. It's almost like diagonal. So this angle right here would be congruent to this one right here. Whereas in the other corners, like the bottom left and the top right, are opposite angles, and so they would be congruent to each other. The next one says that consecutive angles are supplementary. So if you know what supplementary means, this means that they sum to 180 degrees. Now, something that you might not be familiar with is consecutive. If you think about consecutive, like consecutive numbers are numbers that follow right after each other. So 1, 2, 3, 4, that's consecutive. So consecutive are things next to each other. So if I want to show consecutive angles, they're the ones next to each other. So like this angle is consecutive to this one over here, because they're right next to each other. You could have also gone the other way around the parallelogram and said that, let's see if I can use a different color, this angle is consecutive with this one. So you can go all the way around and label consecutive angles, and any of these pairs should be supplementary. So if I were to add them up, they would sum to 180. And now the last property we have here is it says the diagonals blank each other, and it is that the diagonals bisect each other. So there's a word we're familiar with. But where are the diagonals? So you know the word diagonal goes across. The diagonal goes from one vertex to the one opposite it. So right here, there's a diagonal. And we also have another one connecting the other 2 points. So there's our second diagonal. Now, what does it mean if the diagonals bisect each other? So this point here where they intersect in the middle bisects the diagonals so that each one is now broken into 2 congruent pieces. So this point bisects this first diagonal we drew into 2 congruent pieces. and it bisects the other one into two congruent pieces. Now, all four pieces are not congruent to each other. It's just on the same line, those two pieces are congruent. And so they're the properties of a parallelogram. The next one that we're going to learn about is a rhombus. And so a rhombus is in the same family as a parallelogram. It's just a more specific parallelogram. So by definition, right here's our definition. A rhombus is a parallelogram. So if it is a parallelogram, what does that mean? That means its opposite sides are parallel, right? So because it's a parallelogram, I can say its opposite sides are parallel. But now we're a little bit more specific. A rhombus is a parallelogram with four congruent sides. Basically just saying all sides are congruent to each other. So this side is congruent to this one, is congruent to this one, is congruent to this one. All four sides are the same. Now, once you see that you have a rhombus by that definition, now you have some other properties in the rhombus as well. Rhombus. Okay, the first thing we know, the diagonals are perpendicular bisectors. And now these two properties are special here because they kind of also imply that you have a rhombus. So we've got perpendicular bisectors. So we've got our diagonals, which we kind of talked about before. They go from one vertex to the other. Kind of talked about. We definitely just talked about it. All right, there they are. They are perpendicular bisectors of each other. What does that mean? I hope you all are yelling at your computers because you know that perpendicular bisectors are two lines. They are perpendicular to each other, so they meet at a 90-degree angle. And they bisect each other, so they create two congruent halves. That's what it means to be perpendicular bisectors. Another property of the diagonals is that the diagonals bisect the vertex angles. So where are the vertex angles? Now I just highlight that pink so we know what we're talking about. So here, right here, this is the first vertex. I'm going to call it A. The diagonal, that purple line right there, bisects that angle. That means it breaks it up into two congruent angles, right? It's like an angle bisector. And it does that to all of the angles. So let's say this is B. It cuts B into two equal halves as well. And down here, maybe it cuts this one into two equal halves, if I label it C. And then D also gets cut into two congruent halves. So it bisects all four vertex angles. Now we're going to get into these properties that we get once we know it is a rhombus. The first one is that opposite sides are congruent. Now, we know that this is true. We know that all four sides are congruent, really, but opposite sides are congruent specifically. We also know that opposite angles are congruent. So opposite angles would be like A and C. Those are opposite angles. They're congruent to each other. Or the other opposite angles are B and D. Those two are opposites as well. Let's think about this for a second. If the two angles opposite are congruent to each other and they both get bisected, what does that mean about the equal halves that have been created? So like, was too big. Let me do a tiny erase. So like here, B and D, for example, we know that all D and B are congruent to each other. We also know that diagonal is an angle bisector. So if the angles are congruent and I cut them both into two congruent pieces, then what's true is that all four of these pieces are congruent to each other. All right, the next piece says consecutive angles are blank. So consecutive angles here are supplementary. All right, and then the last one, remember supplementary means they sum to 180. And consecutive, again, are the ones next to each other. So A and B are consecutive, B and C are consecutive, C and D are consecutive, and D and A are consecutive. All right, and the last piece says that the diagonals bisect each other. Now, we kind of already knew that, right? We said that the diagonals are perpendicular bisectors. But again, we'll list that the diagonals bisect each other. Do you notice anything familiar with these four properties? They sure look a lot like the four properties we stated above. So notice how they have the same properties, right? And it's because a rhombus is a parallelogram. So they have the same core properties. Now we're going to get into another one that you should be familiar with, and that is a rectangle. So a rectangle is also a parallelogram. It's just a specific kind. So because it's a parallelogram, I know that opposite sides are parallel. So I could go ahead and label that. Now, what makes the rectangle different than a normal parallelogram? What makes it special is that a rectangle is a parallelogram with 4 right angles. So we know in a rectangle that all 4 angles are 90 degrees. Now, another cool property about a rectangle is that the rectangle's diagonals are congruent. All right, so let's look at these properties again down here. Oh, we didn't even draw the diagonals though. Let's draw those in. So diagonal again goes from one vertex to the other. They're opposite. So there's our first diagonal. Here's the second diagonal. And we just said that these two are congruent to each other. Now it's kind of hard to mark without it looking like one piece is congruent to the other piece. So I'm going to erase those, but we know that the full length of the diagonals are congruent. All right, so let's fill in these other properties. The first one is that opposite sides in the rectangle are congruent. So the sides across from each other are congruent, so we can mark those as being congruent now. We also know that opposite angles are congruent. And really, all 4 angles are congruent, right? Because of that property, we know that all right angles are always congruent. That we used a lot in proofs. All right, the next one says consecutive angles are supplementary. And this time in the rectangle, they are also congruent, right? All angles are congruent in the rectangle. And the last property is that the diagonals bisect each other. So that means that this point of intersection cuts the diagonals in half. Now let's think about this. Remember, the diagonals are congruent. So if I cut each one into 2 equal pieces, all 4 pieces should be congruent to each other. All right, and let's look at our last special quadrilateral, and that is the square. A square is a rhombus and a rectangle. That means opposite sides are parallel. All four sides are congruent, right? That's the definition of a rhombus. All four sides congruent. And then what does the rectangle bring in? The fact that we have four right angles. And that's a square. Now, since a square is the same, it's a parallelogram, it is a type of rhombus, it is a type of rectangle, the square has all of the properties of all the quadrilaterals on this page. That means that its diagonals are congruent. Its diagonals, its opposite angles are congruent. Its opposite sides are congruent. Its opposite angles are congruent. Excuse me, guys, I'm sorry. Its consecutive angles are supplementary and congruent for this one, and the diagonals bisect each other. It also means that its diagonals are perpendicular bisectors. The diagonals bisect the vertex angles. Opposite sides are congruent. Opposite angles are congruent. All of these things from all of the other ones are true for the square. That's pretty cool. Let's look at these three on the side. What type of quadrilateral is it? That's what it says. What is it? So in the first one, all that I have labeled is that these two sides are parallel to each other, and these two sides are parallel. So how would you categorize this quadrilateral? If you said a parallelogram, you are correct. Because to be a parallelogram, all you need is opposite sides parallel. Now this next one, I have four congruent sides. 1, 2, 3, 4. What does that one? What could that one be? If you said a rhombus, you are correct. Oops, and I spelled rhombus wrong. Rhombus. All right, and the last one. What would the last one be? So in this one, I have two diagonals that bisect each other, and they meet at a right angle. That means that those diagonals are perpendicular bisectors, which is a property of the rhombus. So there are three examples of some of these special quadrilaterals.